Welcome to the lecture about the Lighthouse project in RANCHI. My name is Christian Kaiser. I'm scientist in the Department Inorganic Materials and Recycling at the Fraunhofer Institute for Building Physics in Germany. There I research and sustainable building materials. Today we will look at how we could improve the carbon footprints of building materials by adding, for example, biochar. As we have already learned in module 3.6, the production of cement generates very high amounts of CO2. You can see that cement production is responsible for CO2 emission about 2.8 billion tons worldwide. At the same time, cement-based building materials have very many positive properties. For example, we can use concrete to construct very stable and durable buildings and other structures relatively cheaply. One way to improve the carbon footprint of cement-based building materials is to use biochar. So, what is biochar? It is produced from plant biomass that accumulates in agriculture, gardening and landscaping, municipal collection or whatever. For example, straw green, cuttings, solid manure, slurry of sewage sludge. These materials are carbonized at high temperature, above some 100 degrees Celsius, and in absence of oxygen. This process is called pyrolysis or thermolysis. This process allows CO2 to be stored in the coal over the long term and not released again. However, for biochar production to be profitable, worthwhile applications for it must be found. Currently, biochar is already being used in agriculture, but an application in building materials is also conceivable. If we manage to add biochar to the building materials and the properties of the finished building materials remain the same, we'll have the opportunity to significantly improve the eco-balance. At Fraunhofer IBP, for example, we are researching the addition of biochar to building materials. In the following, we will now show you how we produce a mortar with an aggregate of biochar. Here you can see the individual components that can be used in the production of that mortar: cement, gravel, sand, water and biochar. The mixing process and the ingredients expected of the addition of biochar do not differ from the standardized production of a standard mortar. But due to the high porosity of the carbon material, the water content of the mixture must be adjusted. Regarding the biochar, it should also be mentioned that it can have also very different properties. For example, depending on the pyrolysis process and the feedstock material, the particle size distribution shows a large difference. An unification can be achieved by an upstream grinding process. The ingredients are now mixed together in a defined ratio in our laboratory. Biochar does function like a pigment, and you can see it changes the color of the mortar. Biochar can therefore also be used for coloring. After curing, the test specimen can be removed from the mold. The curing time should be like normal mortar. If not, then the recipe was probably not correct, or the biochar is not suitable for the production of mortars. These pictures show the material under the microscope. Ideal, we see a mortar in which the carbon material has dispersed well in the cement matrix. Of course, this depends on the biochar particle size. The test specimen now passes through all test procedures which building material must go through. You have to check the hardened properties like flexural and compressive strength after 7 and 28 days. residual porosity, water sorptivity, flammability, freeze-thaw resistance, acid resistant, and so on. So the biochar is very porous. This has some impact on the production process. The biochar is also very dusty. Dust leads to a risk of explosion in the production process. However, the aim in using the biochar is that we can continue to use existing production facilities, which means that the char must be adapted to the requirements of the existing production facilities. The current approach is to introduce the coal wet into the production process. This avoids the risk of explosion. However, the extraction of this wet coal still presents some difficulties. Furthermore, the addition of this wet coal naturally also affects the general water requirement in the production of building materials. This must of course be taken into account in the further addition of water. So we are currently mainly researching how to integrate the biochar in these existing production processes. Well, you will notice the effects of biochar in cement mortar already during production. The addition of charcoal changed significantly the viscosity and the water demand of the mortar. The following building material tests, you will notice that the mechanical strength of the mortar specimen decrease with increased content of carbon. In some, you will notice change in more or less all tests. This means that depending on the properties of the biochar, its addition in cement mortar is limited to a few percent. We guess up to 10%, and the change is slightly and even acceptable. In order for new formulations of building materials to be used on a large scale, they need to be approved by the building authorities. The regulation currently allows us to add small quantities of biochar as a coloring agent. However, the proportion that we are allowed to add is very small. In order to improve the equivalence of building materials, the proportion must be increased. However, we can see that a lot is currently happening in the market. Cement producers are under very high pressure to significantly improve the life cycle assessment of their products in the near future. We therefore expect numerous products with biochar additions to come onto the market in the coming years.